Hello friends, welcome to RR Digital Big Data Hadoop training.
Today's session we'll discuss about Apache HBase module. So this Apache HBase module initially came from Microsoft company. Later Microsoft hand over HBase module to Apache company. Okay, so basically this Apache HBase module implemented on top of HDFS module. Okay, so backend at the end it will store data inside HDFS only. So this HBase module, most of the telecom domain companies and retail domain companies, okay, and social networking companies, so they are using this HBase module. Okay, so for example, if you consider telecom domain companies, okay, to store audio recordings, okay, so call detail records. So what they will do, generally they will process that recordings, okay, so audio files using web services, Java web services. At the end, that web services framework backend, it will connect to Hadoop HDFS. Okay, so inside HDFS, call detailed records it will store. So here we have few topics. Okay, so introduction to Apache HBase. So first I will cover about introduction, and then HBase data model means HBase architecture, and then HBase shell. Shell means here practicals. Okay, so queries I will explain. Okay, so how to write HBase queries and how to enter into HBase command prompt or HBase shell mode. Okay, so those all I will explain, and also how to connect a Hive module from HBase, how to update a record in Hive. Okay, so using HBase you can connect to Hive, and you can update a specific table related record in Hive. Okay, because initial Hive versions, Hive was not supported by DML commands like update, delete, not supported. So at that time, many projects using HBase, they connected to Hive table, and they updated records. Okay, so that concept also important concept I will explain. And introduction to Apache HBase. Okay, so basically HBase is a open source. See, in Hadoop, all the components are models open source only. Okay, like Hive or Pig or Scoop, all components are open source only. Okay, and distributed. So distributed means backend we used HDFS, right? So basically our data, it will distribute into different data nodes, different machines. That is called distributed. So sparse means here it will not allow you to store null values or empty values in HBase. See, basically Hive, if you not pass any value for a specific column related, then it will allocate space, but null or empty it will store. Okay, but here HBase, generally it will not allocate any space, and it will not allow you to insert any empty or null values in HBase. That is called sparse. Multi-dimensional. Okay, so multi-dimensional means basically in a HBase backend, it will store data in a key value pair format. Why key value pair format means here, if you store your data in key value pair format, uh, storage and retrieval will be very fast. Okay, so that's why by default in a HBase it will store data in key value format. And sorted. Okay, so basically sorted means in a HBase, okay, by default whenever you are trying to insert your data, it will apply in sorting order. While inserting itself, it will apply sorting. Also, whenever you are trying to retrieve the data, that time if you look up using a key, then it will be very fast retrieval. Like based on key, if you try to retrieve a value, then it will be fast. And a map, we know basically map, it will be associates keys to values. So each key, it will map to values. And persistent, so persistent basically in a HDFS, once you've written your data, that will be available until you remove. Okay, so HBase is basically a column oriented database on top of Hadoop they implemented. See, column oriented database means basically we have RDBMS, right? So RDBMS basically data it will store row wise. Okay, but in a HBase data it will store column wise. That is called a column oriented database. Okay, how it will store column oriented, that later I will explain. Okay, and here row key. Okay, so row key is mandatory whenever you are trying to insert your data in HBase. Okay, compulsory row key is mandatory. Okay, so without row key it is not possible to insert your data inside HDFS or HBase. So this row key basically it will work like your primary key. Okay, and column families. Okay, so in terms of columns families means basically in a Hive we have a queue name or database names, right? Okay, so one database contains n number of tables. Okay, so here whenever you are trying to define any column, compulsory you have to define a column family name. So that particular column is belongs to which column family, that you have to specify here. Okay, and coming to versions, qualifiers I will explain later. Versions, so basically here employee name column is there. Okay, employee name column, so I inserted employee name value as Ram. Okay, so in HBase first value it will consider as a v1 version v1, and again maybe after some time I updated a value for employee name. Instead of Ram I updated Sam. This is called v2 version, second version. So like this backend it will create uh, versions. Okay, so this is a v3 version. Okay, so backend it will keep all the versions. Okay, but default number of versions by default 3 versions. In case while creating a table, if you not specify versions, then by default 3 versions it will store in HBase. And now if you assume fourth value I updated, instead of Harshit again I updated one more value. So now backend what it will do, it will remove this. Always it will keep only latest 3 versions related data. Okay, so this is about versions. So whenever you are trying to retrieve the data, by default it will read v4 version related data latest. Okay, in case if you want old versions related data, then you have to specify in query, then only it will read whether last 3 versions related data or last 2 versions related data. Okay, so this is about versions. Next, automatic partitioning. See, backend HBase will take care about partitioning. Here manually you no need to specify or create any partitions. Okay, so about the scalability we already discussed in a HDFS module, right? So whenever you want, you can increase capacity or you can decrease capacity, because HBase also implemented on top of HDFS only. Okay, and columns, So in HBase, there is no limit. You can create n number of columns. Okay. And a cell, we know timestamp. See, timestamp basically, what is the use of a timestamp means whenever you are trying to insert a record, okay, it will update a timestamp. So this timestamp column, we no need to create. Backend your HBase framework will create this timestamp column in that particular table. Okay. So what is the use means? For example, RAM updated at 4 a.m. Okay. So that information it will insert, and again v2 version what time exactly updated. Okay. Now when user trying to retrieve latest value means it will compare timestamps. So which record updated what time, based on that it will come to know, right, which is latest version and which is second latest version or which is third latest version. So that is the use of timestamp in HBase. And HBase overview. So basically HBase will call a Hadoop plus NoSQL database. Okay, because here column wise we are storing the data, and at the end our data it will sit inside a HDFS. Okay, so HBase also basically from Apache company, and it is a open source project from Apache company, and used to provide a real-time uh, randomly you can read your data or you can write your data. Also compared to Hive, here you can process very large tables like billions of rows or millions of columns on top of your commodity hardware. Okay, so here we have HDFS. If you use a HBase model, or if you use a pig, or if you use a Hive, any model, at the end your data it will store inside HDFS only. Okay, so RDBMS row oriented, row wise it will store, even Hive also row oriented, but only your HBase it is column oriented. Okay, so HBase is built on top of HDFS. Also HBase files are internally where it will store means inside HDFS. So next concept, HBase plus a Hadoop offering. So Hadoop offerings we already discussed when we started HDFS model. Okay, so we discussed about the fault tolerance and the scalability, and backend how mapper and the reducer will involve. Okay, and HBase basically randomly it will read your data and writes. Also high throughputs means more number of records it will insert in less time. Okay, so it will not take more time to insert more records. See, basically Hive it will take more time, but in a HBase will insert your data very fast. That is called high throughputs. What is the difference between HBase and HDFS? Okay, so HBase we know built on top of HDFS, and it will provide a fast record lookup for large tables. And HDFS basically it is a file system. Your data it will store inside HDFS, and it does not provide a fast individual record lookup. And in HDFS data it will store in flat files, but HBase your data it will store in a key value pair format. Also column wise it will store your data in HBase. Okay, and next HBase it is a NoSQL database. So generally basically people will call that HBase is a NoSQL database. Okay, also that runs on top of a Hadoop cluster, and it will provides a random real-time read or write access. HDFS good for sequential data access, and record level insertion HBase is supporting, but HDFS not good for a record level insertion or incremental addition of existing data. Also HBase supporting for updates means if you want to update a specific record, HBase is supporting, but HDFS are not good for updates. So HBase is not a traditional RDBMS, so like it will not work like your RDBMS. Okay, so HBase is completely different. So data layout in RDBMS row wise it will store, right? But in a HBase column wise it will store your data. And the transactions, so RDBMS it is supporting online transactions. Okay, yes. Here HBase single row. And a query language, basically RDBMS will call structured query language SQL, but here we'll call NoSQL DB. Indexes concept RDBMS is supporting, but here row key we have to consider as indexes are primary key. Maximum data size RDBMS terabytes it is supporting, but your HBase petabytes plus it is supporting. So compared to RDBMS, HBase is supporting maximum size of data. And read and write throughput limits. Okay, so here for second RDBMS 1000 queries it will insert, but here for second millions of queries. Okay, so if you use a large cluster, if you are using a supercomputer, then millions of queries it will insert. And the data RDBMS good for only structured data, but HBase supporting to process semi-structured data as well as structured data also. So about null values we already discussed, right? So in a HBase good with the sparse tables means it is not generally it will not allow you to insert null records, but RDBMS are not optimized. It will allow. How it will store column wise in a HBase? How your data it will organize as column oriented. So here this is row wise. Okay, so you can assume this first table Hive, and this is the second table your SQL RDBMS, traditional RDBMS, and this one your HBase. Okay, so here first row if you see serial number here 1 RID. Okay, and here some URL. Okay, this is ID again name. Okay, so here also data stored row wise only. So same here if you see HBase home, here also HBase home. Okay, so this same row wise data here it will insert column wise. So here HBase Apache here it is there. Again here 3 of G4J. See here column wise, and again here HBase home. So in RDBMS or Hive, generally data it will store row wise, but here same that row wise data here it will store in column wise. That's why basically HBase will call as a column oriented database or NoSQL database. So HBase data model, coming to second topic, HBase data model. So here every row has a row key, so row key is mandatory. Okay, so to recognize a row, here row key is mandatory, compulsory. We have to consider one column as a row key. Also rows are sorted by row key for fast lookups. Okay, also rows are sorted on insert. Okay, so this already we discussed, right? See, when you are trying to retrieve the data, that time it will not apply sorting order. While inserting data into HBase, that time itself it will apply sorting. Okay, here scan means basically to retrieve data, here we'll use scan command. That's why not during scan means not during a retrieval time. So while inserting data itself it will apply sorting. And selecting appropriate keys for your application is critical for performance. See, in a HBase, if you are trying to read your data, Based on key, if you apply, it will give fast performance. Results will give fast retrieval. Or if you are try with a different column, it will take more time. Okay, so based on key, if you retrieve, it will give good performance because in a HBase backend, your data, it will store a key value pair format. And the timestamp of an HBase cell. So about timestamp, we discussed, right? Whenever you are trying to insert a record in a table, that timestamp column, your HBase framework will take care. And what time exactly we inserted that particular record, that time it will update. Based on that, whenever you are trying to retrieve specific version related data, then a timestamp will help you to retrieve. Okay, so here HBase column family attributes. Okay, so in a HBase we have few concepts. By default, our framework will take care. Compression technique. So compression backend, it is supporting uh, none, gz, lzo, snappy. Okay, so if you not specify, by default it will consider none. And versions, default one version, it will possible versions 1 plus, like n number of versions, but a default number of versions 3 it will consider. And a block size, in a HBase block size 1 by 2 2 GB, 1 by 2 2 GB. Default block size 64 K, 64 KB. Okay, and in memory true false, by default false. Okay, if you want, you can enable true. Block cache true false, by default true. Okay, so this basically, whenever we need, then we can enable this true or false. If in memory concept is required, then you can make it true. And block cache, anyway, we no need to do, by default to true. Versions, while creating a table, we have to specify. In case if you need more than 3 versions, then you have to specify. If you not specify, by default it will consider 3 versions. Compression means basically, see, backend it will apply zip and unzip, right? So if you zip your data, size will reduce, right? Okay, so that your storage, HDFS storage will save. Okay, so designing tables. Okay, so for example, here we have client. Okay, so client have one record. Okay, so that record, if client want to retrieve, okay, backend, these two basically you can assume HDFS. Okay, your data is there in HDFS. So first it will check which column is related to which column family. Okay, so if column family 1 related means, it will send here. From here it will go to HDFS. From there it will read your data. If specific other column is related to your column family 2, then it will go to here, and from here it will read your data. So you people will get more clarity when we start explaining HBase architecture. Okay, Hive disadvantages and HBase advantages. Okay, when we process terabytes of data, at the time Hive process will be very slow. That is one drawback in Hive. Also, Hive doesn't support DML commands in older versions. Okay, even still now also, many companies, they are not using DML commands in a Hive model. They are using some other models. And a HBase advantage, HBase is basically alternative for Hive, and also it will run on top of HDFS. Also another advantage, backend it will store your data as a key value pair format. Compared to your Hive, HBase is 10 to 12 times faster if you are processing terabytes or petabytes of data. See, your data size is GBase or MBase, then not much difference between Hive and HBase. But if you are trying to process a large data, terabytes or petabytes of data, that time it will give 10 to 12 times fast. Also, HBase supporting updates. So if you want, you can update specific record or specific value. Also, we know, right, there is no space wastage in HBase because null values it doesn't allow you to store. Also, by default, HBase is storing 3 versions of data, right? Like 3 old versions related data. Or if you want, you can increase the 6 versions or 10 versions. We'll discuss about HBase architecture. So earlier we discussed about HDFS architecture and Hive architectures, right? So similar way in HBase we have one architecture. From HBase architecture, two important nodes we have. Okay, so one node it will be added to the master node. Okay, and another node they added in slaves. So here if you see name node, map reduce job tracker and a secondary name node. These all basically HDFS master nodes. Okay, so along with these three, from HBase they added one more master node, that is a HBase master node. So this node, if they are using HBase, then only this will be available in cluster in their project or their cluster. If a HBase component available, then only this master node will be available. Okay, if they're not using, then this master node won't be available. And coming to slaves also, in a HDFS we have data nodes, n number of data nodes, and each data node contains a task tracker, right? Okay, so basically from HDFS these two we are calling as slave nodes. Okay, so if HBase is there means one more new slaves is available, that is a HBase region servers. So basically this HBase region servers will come under slaves and a HBase master will come under master nodes. So if HBase component available in your cluster means two nodes extra will be available along with your HDFS nodes. So this is HBase architecture here. Okay, so here client, so client means maybe you or your job. For example, I am trying to store the data, so that means I am the client. Or maybe you scheduled one job. Okay, so daily so on so time that job automatically it will execute, then the job will call as a client. This client, if any request will come, then it will connect with HMaster. So to connect with the HMaster here, Zookeeper basically it is a mediator between your client and the HMaster. Also, Zookeeper always it will uh, track all HMaster related and H region. Okay, these both are active or not, these both are running or not. Okay, so these kind of monitoring activities also Zookeeper generally it will take care. Okay, so whenever some request will come from client, then this Zookeeper will accept that request and same request it will pass to HMaster. And again, whenever this HMaster will give response back, then that response it will take from HMaster, then Zookeeper will pass that response back to client. So this is about Zookeeper and client. Now, what is the use of this HMaster? So basically this HMaster is master node, right? So in a HBase architecture, this HMaster it will store your HBase tables related metadata. Which table related data available in which region server or which region or which data node. So all this information available in HMaster. Basically, this is like your HDFS. We have that name node, right? Okay, so similar way here HMaster for HBase HMaster. Okay, so if you want to retrieve any data, or if you want to store data using HBase, compulsory HMaster we have to contact. So who will help us to connect with the HMaster means Zookeeper. So now if you have data file, if you are using a HMaster, okay, then immediately that request will goes to HMaster. Then HMaster will assign a region server. Okay, so here if you see H region server. So basically in real time, parallelly we have multiple region servers. Okay, so these region server it will so each data node contains one H region server. Okay, like HDFS we discussed, right? Each data node contains one task tracker, individual task tracker. Okay, so here also each data node contains one H region server. So if you have n number of data nodes, then n number of H region servers. Okay, so this H region server, okay, whatever data it will come from HMaster. Okay, so that data it will like if it is data insertion like a read operation or write operation, or it is a delete operation. Okay, so those operation related requests, this H region server it will assign it to H region. Yeah, so here H region is there, right? So this region server it will assign it to H region. So we have n number of H region servers, and inside that H region server H region also available. Now this H region it will store your data in a H file. So H file that is basically temporarily your data it will store inside H file. But whenever this H file is going to full, like this memory is going to full, then it will send that entire data to data nodes. So this DFS client, what is the use of a DFS client? See, basically DFS client, it is mediator between your data node and a H region server. Okay, see, both will run in same machine only. Okay, but this is basically built-in jar file DFS client, built-in framework or jar file. Okay, so this jar file, this client, it will help you to connect with your H region server and data node. So whenever this H file want to push data to inside a data node or HDFS, then this DFS client will help. So reading it will help, and writing it will help both. Okay, whenever you want to store your data also it will help, or whenever you want to read also, this DFS client will help. So once this data it move to data node, then here again a space will be free, right? So whatever new data will come again it will keep here. Okay, after some time again it will full, right? Then again it will flush to data node. Okay, so all these H files will work like that only. Okay, so it will keep till that memory is full. Once that is going to full, then it will flush to inside data nodes. Coming to memstore. Okay, so memstore basically always it will keep new data, latest data. See, we discussed about one version related data, it will keep in HDFS. Okay, but HDFS doesn't support updates, right? Okay, instead of some value, if you want to update different value, HDFS is not supporting, right? So that V2, V3 related updates, it will keep in the memstore. So this HMaster knows that where is V1 version related data and where is updated data. So HMaster knows that, okay, V1 data available in HDFS and V2 or V3, V4 available in memstore, because HDFS doesn't support updates. That's why this memstore always it will keep updates related information or data. So this is about HBase architecture. See, also here we have H log, right? Okay, so this hlog generally it will generate log files. Also, whenever when you are trying to execute your job, okay, if any kind of errors or logs, okay, so those also this hlog will capture basically. We'll discuss about HBase commands. Okay, so before executing HBase command, so first we have to enter in HBase shell mode. Okay, so for that we have to enter command HBase space shell. Okay, so this is the command which will take you to the HBase shell mode. Okay, so successfully logged in HBase mode. So here we can see HBase version 1.2.0 and Cloudera version 5.13.0. So first we'll check what are tables available in HBase. Okay, so to check existing tables we have to use list command. Okay, so here it is showing only a DEPT table. Okay, so only one table available, that is a DEPT. And also if you want to check which user logged in, okay, then you have to give command who am I. Okay, so here it is showing Cloudera user logged in this console, and this particular user belongs to Cloudera group and default group. Next, how to create a table in HBase. Okay, so create table name, employee, okay, and a column family name. Okay, so this particular table belongs to which column family. Okay, so create table name employee. Okay, and column family name here CF1 I am giving. Okay, so before creating a table or while creating a table, compulsory we have to specify column family name. Okay, so table successfully created. Using a list command we can cross verify. So here it is showing employee table. So we have created table, but we have not specified any column names, or we have not inserted any data. Okay, now we'll insert a few records. So before inserting, if you want, you can describe a table. Okay, so this is the command describe table employee. Okay, so here it is giving information. This particular employee table is there in enabled mode. Okay, so here we have two modes, enable mode and a disable mode. Okay, so here it is showing it is enable mode. Column family name which we defined, that it is showing here CF1. Okay, so these are backend by default it will provide this information. Okay, these are the default configurations. Okay, so now we'll insert data. So to insert data we have to use a put command. Okay, put employee, then row key is mandatory, so row key 1 I'm giving here, and then which column related data you want to insert, employee name. Okay, so before column name here we have to define column family name. Okay, and then employee name related value. Okay, so here I am giving ram. Okay, so successfully inserted one record. Okay, so after inserting, how to retrieve the data from HBase table. So for that we have to use scan command. Scan in table name. Okay, see here it is showing one record. Okay, and column family name, employee name, and value we inserted as ram. Okay, and this timestamp what time exactly we inserted. So we have inserted only one column related, but the same row, same record, I want to insert another column related data. Okay, so maybe salary related data also. Okay, so here maybe 5,000. Okay, so this row key is same. Okay, so row key is same means we are inserting record in for the same. Okay, it is not different record. If you give here 2 means that is different record. Okay, but you are giving existing row key. That means this is a new column value we are inserting into existing row. So successfully inserted, and again using the scan command we can check. Okay, so here it is showing only one row because yes, only one row. Employee name and salary both are different columns but a single record. Okay, single record contains two different columns related data, employee name and salary. I will insert a different row. Here I am giving row key 2. Okay, and employee. See, now here it is showing 2 rows. Okay, because these two single record, this one single record. Now how to retrieve specific row key related data? Okay, so here get and then table name employee and then row key. Okay, so row key 1 related data you can retrieve. Okay, see, successfully retrieved row key 1 related. Okay, so using get command you can retrieve specific row key related data. If you use scan, by default all the records it will show. Okay, but based on a row key, if you want to retrieve data, you can use a get command. Okay, and if you want to check how many records are there in employee table, then you have to use count and then table name. See, here is given count, right? Only 2 records are there. I want to check table is there in which mode. Okay, so here is underscore enabled and then table name. So it is giving a true because our table is there in enable mode only. See, whenever generally we create a table, by default it will be enable mode. You can try disable also. Disabled is underscore disabled. What it will give? False, right? Because it is there in enable mode. Now I want to disable this table. So disable then table name. Table disabled. Now you can cross verify is underscore enabled. What it will show? False because disabled. And is underscore disabled. What it will display? True. Okay. So table successfully disabled. Why we have to disable table? So whenever you want to hide your table related data to others, then you can disable. Okay. So now if you try scan command, it will not give result because it is there in a disable mode. Okay, that's why it will not give results. Now you can enable. Okay, and then you can try scan command. Okay, enable. So now table is enabled, so it will retrieve the data now. Okay, so basically this is about enable and disable. Okay, how to drop table? Drop or truncat. Okay, so drop table name employee. Okay, so if you want to drop table, first you have to disable. So disable table. Okay, table disabled. Now drop. Okay, so successfully dropped. See, list, it is showing only department table, there is no employee table. Okay, so now we'll create again a table. Okay, so here I will specify versions also. Okay, okay, table created and I specified 3 versions. Describe table name. So here it is showing 3 versions. Okay, now we'll insert data. Okay, So using a put command, I will insert a data using a put command. Okay. So here employee name I am inserting. Okay. Name Ram. Okay. So this is V1 version related data. Now instead of Ram, I am updating Sam. Now again instead of Sam, Ramu. So in HBase, it will store last three versions related data. Okay. Scan employee. But when you use a scan command, always it will read only latest value, not 3. Okay. So here scan employee, then versions here 3. He successfully retrieved last 3 versions related data. Okay. So if you update a fourth value instead of Ramu, again if you give Ram1 means now it will give only 3. So first value, this one it will remove. Always only latest 3. Okay, backend also it will keep only latest 3 values related data. Now, how to truncate table? Truncate table. So truncate means data it will remove, but table it will keep. Okay, so here you can check a list. It is showing employee. Okay, but data scan employee because we applied a truncate. Okay, so data removed. Okay, so status simple. Okay. So generally this status command Hadoop admin team will use. Okay, so whenever they want to check a cluster related or HBase related information, so what all are nodes running backend and the server is live or not, how many backup servers are running. Okay, so that time they will use this command status simple, and also here it is showing how many number of regions also running. Okay, and instead of simple summary also you can try. Summary just what is what it will give, how many servers, how many dead, how many are active, how many are running, like that. Okay, and the next one detailed. Okay, detailed means if each region server related all the information it will show. Okay, basically this information required only for a Hadoop admin team. Okay, for developers it is not required, but just knowledge purpose I explained here. Okay,
Please subscribe our channel for more training related videos.
we are going to discuss about HBase managed Hive table. So HBase managed Hive table, this is basically important concept in HBase model. Okay, so earlier Hive 0.14.0 version Hive not supported
DML statements like
delete, update, those commands not supported. Okay, so that time most of the projects using HBase, they can connect a Hive model, and inside a Hive model you can connect a specific table and you can insert your records from HBase to Hive table, or you can update records in Hive, or you can delete records from Hive. So this concept we are calling as HBase managed Hive table. So now we'll see how to implement this concept. Okay, so here we have to follow some steps. So step 1, we have to add all these supporting jar files in Hive prompt. Okay, after that, second step we have to create a temp table in a Hive. Then we have to load data into temp table. And fourth point, we have to create HBase managed Hive table. Okay. So when you create this HBase managed Hive table, same table it will create in both the places. Like Hive side also it will create, and same time HBase side also it will create. So we have to verify table created in Hive and HBase. And the next point, insert data into managed table from a temp table. So here we have created temp table, right? So this temp table contains data, right? Same data you can insert into this managed table. So when you insert this data, Hive side also it should insert, and same time HBase side also data inserted or not, that we have to verify. And next, HBase side, same table you can insert a new record. Same new record it is inserted into Hive or not, that we have to check. Okay. And the next, update record in HBase. Same changes it is reflected in Hive or not, that we have to check. So here concept is, using HBase you can update records in Hive or you can modify records in Hive. Okay. Same time using Hive also you can reflect the data in HBase. Okay. Now we'll follow one by one. So first step this one. Okay. So add jar, all the jar files. Okay. Here if you are using Cloudera 5.14.0, then you can give 14.0 jar name. Okay. So in my laptop I'm using 5.13.0. Okay. So here Hive. So I'm adding all the supporting jar files successfully added. So step 1 completed. And the next step 2. So here step 2, create a temp table in a Hive. Okay. So for that we need the data file, right? Okay. So here cd data ls. Okay. So cat, here we need one data file, Hive HBase.txt. So this is the data file. So for this data file we'll create one a table first. Okay. So here this is a Hive, create table, table name, student, student number, student name, student passed out year, student marks, student region. Okay. So region string, row format, delimited, fields terminated by, fields terminated by. So your data separated by space. Okay. So here I am giving a /n. Successfully created table. Here show tables. So student table it is showing. Now we'll load the data into student table. Okay. Load data local in path home Cloudera data your data file name hive hbase.txt, hive hbase.txt. Okay, into table student. Okay, so temporary table created and the data loaded or not, that we'll check now. Okay, so select star from student. Okay, so data successfully loaded. So we have completed 3 steps now. Okay, next fourth step, create a HBase managed Hive table. Okay, so we'll see how to create that table. Okay, so here, so now whatever table we are going to create, it will create a table in both the components. Hive side also it will create, same time HBase side also it will create. So create table student one, so student number, student name, string, data type, student passed out here, and student marks, student region, region. Okay, so all the columns are specified. So these all the columns it will create in a Hive. Okay, so stored by, okay, stored by here org dot apache dot hadoop dot hive dot then HBase dot HB capital letters HBase dot storage handler store. So here dot not required. So HBase storage handler. Okay. Okay. So this is the package which is available inside HBase jar file. Okay, so we loaded 4 jar files, right? Inside that jar file, this package available. Okay, so with SRD properties, with the SRD properties. Okay, and now here HBase dot elements dot mapping, okay, equals to, because whatever columns here we created, those all just it will create inside Hive, but now we are mapping to HBase also. HBase also same columns we have to create, right? Key, comma, so first one student number I'm considering as a key. Okay, then column family name, student name, then again column family name, student year, passed out year, then again column family name, student marks, then again column family name, student region. Because in HBase column, in front of a column name we have to specify column family name. Okay, that's why here my column family name I defined as a CF1. Okay, then EBL properties. Okay, so here HBase dot table dot name. In HBase you want to create a same table name student one or different. Okay, so here I am creating same only. If you want you can give a different name also, but a Hive side and HBase side both I am giving the same name student one. Okay, so successfully created. Okay, now Hive side we'll see table created or not. Show table student one created. At the same time HBase also we have to cross verify. Okay, HBase also student one table created. Okay, now both the components table created. Okay, but we have to load a data, right? We have to load the data from temp table to this table. So here if you see insert data into manager table from temp table. Okay, so for that here we have to execute one query. Okay, so insert into table student one, you can insert data into student one table. Okay, one select star from student. So whatever data available in student table, same data you can insert into student one table. Okay, so now select star from student one. Okay, so data inserted into Hive, and we'll verify even HBase also data available or not. Okay, student one. So HBase also data inserted. So both the places, both the tables, same data inserted. Okay, so we executed query in Hive, but changes reflected in HBase also. Okay, now I will insert one new record in a HBase table. Same record it will reflect in a Hive or not. That will check. Okay, so put student one in employee number, student number, and the column family name CF1. Okay, student name and value. Okay, so inserted scan. So earlier 20 records, now it is showing 21 records. So here, okay, so in HBase successfully inserted new record. Now we'll verify same record inserted in Hive or not. Okay, so Hive also it is inserted same record. Okay, so employee name only we inserted, but remaining three null. Okay, because HBase we inserted only one column related data, not other columns related data. Now what we'll do in HBase, we'll insert here instead of null, it will update here or not, that will check. Okay, so HBase here. Okay, same record here column. So here I will give 2022. Okay, so now go to Hive. You check. See, previously null, now it is updated. Instead of null, it is updated 2022. Okay, so using HBase managed Hive tables concept, you can insert or you can update records in Hive using HBase. Thanks all for watching this session. Bye friends.